All right, so 3, 4 is proofs with perpendicular lines. There are 2 proofs on your test, so this is going to give us some practice with some of them, okay? But we're going to talk more about like the actual perpendicular line situation. So this is distance from a point to a line. The distance from a point to a line is the length of the perpendicular segment from the point to the line. It's the shortest distance between the point and the line. So if I asked you to, if like, let's even say the AB segment was not there and I just asked you to give me the distance from A to this line, you would want that perpendicular segment. So none of these segments would work as distance. It has to be the one that's perpendicular, okay? It's the shortest distance between 2 points or the shortest distance between a point and a line. Example 1 says find the distance from point A to line BD. So point A is here, line BD is here. How do we find the distance from that point to the line? Distance formula, which is?
A lot of things.
D equals square root of y. Square root of
Keep going.
y minus
What?
y1 y2 plus minus y1.
Keep going. It could be y. It's usually x, but the order really doesn't matter. X2 minus x1 squared plus y2 minus y1 squared. Okay, and you could have switched that. Like switching out the x and y is fine as long as you group them together. So for that, I need the actual coordinate points at A and at C, which is the end of this perpendicular segment. So it doesn't matter which one you make the 1s and which ones you make the 2s, as long as you're consistent. If this is x1, y1, then this is x2, y2. And I'd get the square root of 1 minus a negative 3, which becomes plus 3, squared, plus negative 1 minus 3 squared. I get the square root of 4 squared plus negative 4 squared. 16 plus 16, square root 32. And then we have to simplify it. So 32 is divisible by 2. Relax. 2 and 16, which could be 4 and 4, or keep going. 2 and 8, 2 and 4, 2 and 2. And then for each pair of 2s, one's going to go to the outside. And the single 2 that doesn't have a partner stays underneath. So this is 4 square root 2. Your homework is going to say round to the nearest tenth. When you type that answer in onto Big Ideas, you can go ahead and use a calculator to round it. But on your work on your PDF needs to be the simplified square root because that is how it will be on your test. So you won't have a calculator on your test to round anything. You'll keep it as an exact answer, which means a simplified square root.
So on the homework assignment? So
on Big Ideas, when you type in your answer, you're going to type it in as the rounded decimal. On the work, you have to show it like that. All right, a perpendicular bisector, and if you think about the 2 parts of that word, the perpendicular part means there's going to be a right angle, the bisector part means it's cut in half. So a perpendicular bisector of a line segment, hang on, I'll go back in a second, is the line with the following properties. It is perpendicular to the segment, so line N in this drawing is perpendicular to line, or to segment, PQ. And it passes through the midpoint of that segment. So it has to be at its middle, which will be marked with either the congruency marks or it will say M is the midpoint. And it has to have the right angle boxed, showing that it's perpendicular. The linear pair perpendicular theorem, okay, it's a mouthful. It is, you could put LPP theorem, okay? It says if 2 lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if it is 2 angles and they are congruent, obviously we know that if it forms a line, it would have to add up to 180, divide 180 by 2, and I'd get 90 and 90, which is where this comes from. So again, we can shorten this to LPP theorem. Okay, but it is not just linear pair postulate, right? Linear pair postulate says that they add up to 180. This is now saying if they are congruent, then we go a step further and say that these lines are perpendicular.
What's the difference between, oh my gosh, my favorite thing.
What's the difference between what? All right, the other theorem is called the perpendicular transversal theorem. And it says in a plane, and that's important because otherwise they could be skew. So in the same plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So it's kind of like the transitive property with perpendicular, but it doesn't work because it has to be in the same plane, so it has a different name. Perpendicular transversal theorem says if in a plane a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. So in this diagram, you have to have the two parallel lines, which we do. H is parallel to K. And then you'd have to know that another line is perpendicular to at least one of those. And because J is perpendicular to H, then I can determine J is also perpendicular to K.
Can H be transverse property
No.
equality?
No.
The last test of the course.
All right, lines perpendicular to a transversal theorem. Oh, that's what now we're talking plural. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So we're kind of reversing what we just said. And the other one, we said they're parallel, and one is perpendicular, which means the other one is also perpendicular. Now we're saying if two lines in a plane are perpendicular to the same line, then they're parallel to each other. So this is now the sixth way to prove lines are parallel. Okay, so we can add this to our list. We had 5, which means it's alternate interior angles, converse, alternate exterior angles, converse, corresponding angles, converse, same side interior or consecutive interior, converse, the parallel transitive property, and now lines perpendicular to a transversal theorem.
That's a lot.
Yep.
I don't understand
like that.
what you said. I agree.
Okay, there are now 6 ways to prove lines are parallel.
Let me take a picture of this.
First way, alternate interior angles, theorem, converse. What does that say?
That, there's two alternate interior angles that are the same measure than the parallel.
Okay, if alternate interior angles are congruent, then the lines are parallel. Then we had alternate exterior angles, theorem, converse. And that says what? Jonathan.
Two alternate exterior angles are congruent, like their two lines are parallel.
Good. If alternate exterior angles are congruent, then the lines are parallel. 3, corresponding angle, theorem, converse, which says what has to be true about corresponding angles? Yep.
If two consecutive angles, one.
Well, wait, not consecutive, corresponding.
Rookie mistake.
Consecutive is next.
No, but they're consecutive, they're on the same line, it's on the same side, but one's exterior and one's interior. I don't know how to describe it. And then
Well, but by definition, they're just called corresponding. So if corresponding angles are congruent, then the lines are parallel, right? Then there's consecutive interior. And what has to be true about consecutive interior angles? Yeah.
if they equal 180.
Good. Those are the only ones so far that have had to be supplementary. Okay. If consecutive interior angles are supplementary, then the lines are parallel. I'm not done, guys. There's 6. 5.
LPV theorem?
Not yet. Fifth is transitive property of parallel lines, which says that if two parallel lines are if one parallel line if one line, yes, is parallel to a second line. So let's just say if line M is parallel to N and M is parallel to L, then N is parallel to L. So if two lines are parallel to the same line, they are parallel to each other. That's the transitive property. And then we just added lines perpendicular to which basically just says if two lines are perpendicular to the same line, then they are parallel. So if I would say all of those, the names are pretty easy. If you forget that name at the end, then just know what it says, which is if two lines are perpendicular to the same line, then they are perpendicular, then they're parallel to each other. Yeah.
Do we memorize?
All right, example 2 says the photo shows the layout of a neighborhood. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. So give me some parallel. Yes, there are some, right? So just give me, and see the names. I know they're hard to read, but at the top is S, T, U, and on the right is P, Q. Jonathan.
P and Q are both parallel because they're both perpendicular to S.
Okay, P and Q are both parallel because they are perpendicular to line S. Okay, so two lines perpendicular to the same line, which is that big long theorem. Okay. Anything else? Yep.
U is parallel to T
How do you know that?
because I know it for many reasons actually.
Give me one that's gonna work.
Alternate interior,
Mm-mm.
It's not right.
alternate exterior,
It's not.
Mm-mm.
corresponding.
It's
Nope.
not.
They're not, actually. TU does not have enough information, but there is another pair there that does. Sophia.
CNS.
T and S. And why?
Because they're perpendicular.
Same reason, right? Two lines perpendicular to the same line. So if you didn't remember that theorem, then you could go as far as even to say those are both 90 degrees. If they're both equal 92 degrees, then they're equal to each other, and that would be substitution. And then because they're equal to each other and they're corresponding angles, you can use the corresponding angles theorem converse. So you could get there in a couple more steps, but if you just know that one theorem, that two lines that are perpendicular to the same line would be parallel, then that's enough.
If I put U is parallel to T on the test,
It would be wrong. It would be wrong.
You're wrong, sounds like.
Why?
Because there's absolutely no information to you provided about line U.
On the test, is
Yeah.
the proof gonna be like we have to write the full thing?
One yes, one no.
Are they gonna be two